But so in reality, let me ask you this: how do epidemics look like? Okay, so here we have these are now illustrations of potential hosts, right? These are people from all walks of life, right? These are very cheerful individuals, and well, one way of answering this question, these are individuals from day-to-day activities, right? And in general, when you take the bus or you take the train or you're waiting in a bus stop or you go to a class in an auditorium or you go to the airport, you board a plane, you go to the gym, right? Go to a yoga class or I don't know, any activity that involves you interacting with other humans. In general, these are the type of phases that this is what you would look. You would look at people, on every day. And so unless there are some very specific signs or specific symptoms, for people to read red flag as being infected, in general, for many infections, how do epidemics look like? Well, they look like this. You look at people around you and you couldn't really tell who is infected and who is not infected. If they're not sneezing or they don't look lousy or something, you couldn't really tell. And in some cases, individuals that are carrying the pathogen, sometimes they don't even know that they are hosting such pathogens, right? So, in general, how do epidemics look like? Well, they may look like this, like the people we hang out and interact with every day. Now, for quantitative individuals, for mathematicians, for statisticians, individuals like you, then this is a way of visualizing epidemics. How do the epidemics look like? Well, this is an answer to that question. They may look like this. This is a snapshot. This is a way of keeping a count. Here there is a count on prevalence. This is a data set. On the horizontal axis we have the observations are being measured every day, once a day, and then on the vertical axis we have measurements or counts on the number of infected individuals. These are individuals in a boarding school in the United Kingdom, and this was an outbreak of the flu. Okay, so this is one example. This data set is called prevalence data. It has to do with the number of infected. Here's another example, again on the horizontal axis. The time, you have time units, and those units are now in weeks. In the previous data set, in the previous example, the measurements were taken every day. Here the units or the scale for the horizontal axis is in weeks. Okay, and these are observations of the prevalence. Okay, this is a data set for an epidemic in 1905 in India. Okay, so in the third example, all these examples I'm just trying to illustrate to drive home the message here that how do epidemics look like? Well, if you have ways of keeping records, ways of counting, having a head count on either the number of infected individuals or the number of new cases, then you will be able to put together data sets that when visualized, displayed, you can create this type of figures. This is the third example. These are observations about cases of measles in New York City. And here the observations, again, on the horizontal axis, these are time units. Now these are monthly observations, right? These measurements were taken once a month. And you can see how, even though this is over a much longer time scale, right? This is easily extending over 30 years with monthly observations. You look here for this data set. This is on the period over 30 weeks. 30 weeks is less than 1 year. 1 year is 52 weeks. This here is in days, right? And it goes for about 2 weeks, right? Between 2 and 14. So this is the most 2 weeks. But you see certain patterns in these data sets, right? Even you can see how they increase, so that they have the shape of increasing up to a maximum and then decaying, right? So they increase up to a maximum and then decay. And here, in a sense, these patterns are consistent. You would have to basically take a snapshot over, not over 30 years, but if you look at what's happening over a shorter time window, then you see how there is a pattern of having a really low level of measurements, and then they grow up to some maximum value, and then they drop, right? But because here this data set is over a much larger time period, we can see that these patterns repeat themselves, okay? But these are examples of standard data sets you find in the literature for standard diseases, infectious diseases.